We are going to see some introduction to graph, how it is represented and what are the elements of the graph we are going to discuss in this class. So first, a graph can be represented by an ordered triplet, that is V of G, E of G, pi. So this is an ordered triplet and this we call it as graph, and here V of G represents a non-empty set of vertices. It is also known as nodes or points. Vertices are also known as nodes or points of the graph, and E of G represents the set of edges of the graph. And here pi represents the mapping from the set of edges, that is we can represent E, to a set of ordered or unordered pairs of elements of V. Now if we look at the example, now consider the example for the graph like this. Okay, we consider this graph where here we have 4 vertices, that is V1, V2, V3 and V4, and we have 5 edges E1, E2, E3, E4 and E5. Here we can represent this graph G as V, E, pi, where V of G is nothing but the set of vertices. So here we have 4 vertices. So V1, V2, V3, V4 will be the set of vertices, and E of G represents the edges of the graph. Here we have 5 edges. So E1, E2, E3, E4 and E5, and pi represents a mapping from the set of edges to an ordered or unordered pairs. Here pi of E1 is nothing but the ordered pair V1, V2, because the edge E1 is incident on V1 and V2 vertices. So pi of E1 equal to V1, V2. Similarly, pi of E5 can be written as V4, V5. Okay. Next, in this graph, we will see what are the adjacent vertices. Adjacent means what? Nearby. So, any pair of vertices which are connected by an edge in a graph is called adjacent vertices. That means here edge E1 is a pair of vertices V1, V2. Therefore, V1, V2 are adjacent vertices. Similarly, E2 edge is a pair of V2, V3. So, V2, V3 is adjacent. Similarly, we can find whether the remaining vertices are adjacent or not. Now, can we find any vertices which are not adjacent? Here there is no edge. There is no edge between V1, V3. Therefore, V1, V3 is not adjacent. Okay. Adjacent vertices means there should be a edge between those vertices. If there is no edge between the vertices, then we can call it as non-adjacent vertices. Next, we see what are adjacent edges. Here, if any two distinct edges are incident with a common vertex, then they are called adjacent edges. Here the edge E1 and the edge E4 incident on a common vertex V1. Therefore, E1 and E4 are adjacent edges. Similarly, the edge E2 and the edge E3 are incident on the same vertex V3. Therefore, E2 and E3 are adjacent edges. Clear? Can you find any non-adjacent edges? Here the edge E4 and the edge E2 are incident on different vertices. Therefore, E4 and E2 are non-adjacent edges. Clear? E4 and E2 are non-adjacent edges. Clear? Next, we come for the definition of isolated vertex. In any graph, a vertex which is not adjacent to any other vertex is called an isolated vertex. That means the vertex has no incident edge. Here you see the edge E1 and the edge E2 are incident on the same vertex V1. But there is no edge between V2 and V3. So here in that graph, V3 is not adjacent to any other vertices. V3 is not adjacent to any vertex. Therefore, here we say V3 is isolated vertex. So, which remains alone from the graph is known as isolated vertex. Okay, clear? Next, we understand what is direct and undirected graph. A graph in which every edge is directed is called a direct graph. It is simply known as digraph. A graph in which every edge is undirected is called an undirected graph. Directed means the edge has a direction from which vertex and to which vertex we can find in which direction the edge is going. So, if the graph has direction, then it is known as directed graph. If the graph has no direction, it is known as undirected graph. Now, look at the figure 1. Here, E1 edge is from V1 to V2. So, E1 we have to write it as V1 and V2. We should not write it as V2, V1, and this is wrong because here the edge E1 starts from V1 and ends in V3. Okay, so we should not write as it is. We should write in some ordered form. Similarly, the edge E2 is from V3 to V2. We should not write it as V2, V3. This representation is wrong. But whereas in figure 2, we can change the order because in the figure 2, the direction is not given. Okay. Now consider this graph. Here, E3 edge is directed, whereas the edges E1 and E2 are undirected. So, if some edges are directed and some are undirected in a graph, then the graph is known as mixed graph. Okay. Next, what is the definition of a loop? A loop is an edge whose vertices are equal. That means the starting and ending vertex of an edge will be same. That means if we have one more edge for this vertices like this, here we can consider this edge name as E4. The E4 edge starts from V3 and also ends at V3. So the starting edge and ending edge is same. So here this is known as loop. Okay. Next, there may have parallel edges in a graph. That means we may have multiple edges having the same pair of vertices. Now if we have one more edges like this between V2 and V3 and we name it as E5, means the edge E2 and the edge E5 have the same vertices V2 and V3. Therefore E2 and E5 are parallel edges. This is also known as multiple edges. Okay. So E2 and E5 are parallel edges. If the graph contains some parallel edges and loops, then it is known as multigraph. If the graph has no loops or multiple edges, then it is known as simple graph. This is suitable for directed graph also. If the directed graph has no loops and no multiple directed edges, then it is called a simple directed graph. Okay. Next, we should learn how to find the degree of a vertex. Now consider this undirected graph. Here the degree of vertex in an undirected graph is the number of edges incident with it, except that a loop at a vertex contributes twice to the degree of the vertex, and the degree is represented by degree of some which vertex, that we have to put it in bracket. Now let us find the degree for the vertex V1. Here we have to see how many edges are incident with it. Here the edge E1, E6 and E7 are incident with the vertex V1. But E7 edge is a loop, so it contributes twice. So the degree of V1 will be 1 plus 1 plus 2, that is equal to 4. Similarly, we can find the degree for V2. Here E1 edge and E2 edge and E3 edges are incident on V2. There is no loop, therefore 1 plus 1 plus 1, that is equal to 3. Similarly, we can find degree for V3 vertex, that is V3 vertex has the edges E2, E3, E4 and E5. 4 edges are incident on V3. Therefore, degree of V3 is 4. Similarly, degree of V4 is equal to, here the edge E6, E4 and E5 are incident on the vertex V4. Therefore, the degree is 3. Okay, like this we will know the degree for the vertex in a graph. Okay. If there is any isolated vertex, for we name here as V5, here there are no edges incident on this vertex. So we can write degree of V5 equal to 0. Okay. And very important topic in graph theory, that is adjacency matrix. Now consider a graph with vertices and edges. Let us assume that the graph has n number of vertices and the adjacency matrix is denoted by AG, and it have the matrix of elements of the form Aij, and that matrix will be of order n. Aij will be equal to 1 if the vertex. We are going to find the adjacency matrix for this graph. Now we can write AG equal to, here there are 3 vertices, so we have to write V1, V2, V3 inside and in up also. Before constructing the matrix, it will be easy for us to write the elements. Now we have to see whether it is adjacent to the vertices. Now we have to complete the first row. Here V1, here also we have V1. Here there is no loop, therefore the element will be 0. Here V1 and V2 are adjacent because there is a edge between V1